Today we're going to take and graph inequalities, but we're going to do it in two variables rather than one. At this point we've been doing everything on a number line for inequalities, and now we're going to put it in an XY coordinate axis and go ahead and solve an inequality based on its graph. Well, if you'll notice here we have an equation, or actually an inequality, of y is greater than or equal to 2/3 x minus 4. Well, the equality part of y equals 2/3 x minus 4 doesn't really change. We can graph that just like we have in the past with our slope-intercept concept. So we go down to 4, which is our y-intercept, and then rise 2 and run 3. We could do that a couple of times if we wanted to, up 2 over 1, 2, 3. Connect my dots, and that's a graph of y equals 2/3 x minus 4. But that's not what we want. We want to find out where y is greater than or equal to. So what I do is I separate my graph into two parts, because you'll see this line splits the graph into two parts. You have a part that's above and a part that's below. And we want to see what points, what x and y values are going to satisfy this solution. So what I do is I pick what's called a sample point. And a sample point can be any point in my graph, but I tend to pick an easy point of 0, 0 if it's on one side of my graph. So I'm going to plug in the point 0, 0 and see if that's in the solution set for this particular graph. Plugging 0, 0 into my original equation, I get 0 is greater than or equal to 2/3 times 0 minus 4. So this says 0 is greater than or equal to negative 4. And this ends up being a true statement. So what that tells me is it tells me that this sample point of 0, 0 is in my solution region for this inequality. So if this is in my solution region, every point in this area is in my solution region. I can check another point just for fun. Here's a point 3, 0. Let's plug that in. All right. And see if that works as well. It should. I get 0 greater than or equal to 2/3 times 3 minus 4. 0 greater than or equal to, that's 2 minus 4, so 0 is greater than or equal to negative 2. That's a true statement as well. So here's two sample points whose values are in the solution set, so all the values in this region are in the solution set. So basically what I do is I shade this entire region. And this is the graph of the solution set of inequality of y is greater than or equal to 2/3 x minus 4. Let's do another one. In this case, once again, we have an inequality, but this is strictly less than. So you remember that when we did number line graphs, we either filled in a circle or we left an open circle. Well, it's somewhat similar when we're dealing with a line. If I take and graph negative 2x plus 5, I go up to 5, 1, 2, 3, 4, 5, and then do a slope of down 2 over 1. Do it a couple of times. But instead of drawing a solid line, what I do is I dot my line. That's kind of like the open circle equivalent. So you draw a dotted line. And then what we have to do, since this is splitting my graph into two regions, I pick a sample point in one of the regions. Again, I like a sample point of 0, 0. So I'm going to plug my sample in and get 0 is less than negative 2 times 0 plus 5. So I have 0 is less than 5. And I have to decide if that's a true or false statement. That's true. So every point in that region below the graph is going to work. So again, I shade in this region where my sample point was. So here's a greater than or equal to problem. We're going to do a solid line, but the issue here is my graph is not in slope-intercept form. So I'm going to have to do that. And you can do this a lot of different ways. I'm going to get the y by itself by subtracting 3x to both sides. The inequality sign stays where it is because I haven't multiplied or divided by a negative to this point. But now I'm going to take and divide each side by a -4. And since I'm dividing by a negative, my inequality must turn around. So negative over negative is a positive here, and positive over negative is a negative. So here's my slope-intercept form. I go down to 3, up 3 over 4. I'll do it again just for accuracy purposes. And then I'll take and connect the line, solid line once again. Like so. And then I'm going to pick my sample point. Once again, I'll pick 0, 0. And I can plug it into either this equation or this equation here. I'll choose to plug it into the top in this case. So sample 0, 0. And we'll say 3 times 0 minus 4 times 0 greater than or equal to 12. So it says 0 is greater than or equal to 12. We have to determine if that's true or false. That's false. So since this point is not in the solution set, none of the points above will be in the solution set. Therefore, I have to shade below. And if we want proof of that, pick a point in the region that I just shaded. Let's do that. Let's pick this point right here, which is 0 and 1, 2, 3, 4, 5. 0, 5. So let's plug 0, 5 in to this equation. If I go 3 times 0 minus 4 times, and that was actually a -5, and see if that's greater than or equal to 12. -4 times -5 is 20. And that should be greater than or equal to 12, and it is. So my graph must be done correctly. Couple of special cases now. You'll notice that I'm asked to graph this in an XY coordinate grid, but there is no Y here. So we have to remember, well, how did we take and graph x is equal to 6? Well, x equals 6 is just a point right here. And this says to graph all the values that are less than 6. But if I want to graph the line that's x equals to 6, where is x equal to 6? Well, it's equal to 6 here. X is equal to 6 here, and here, and here. Pretty much everywhere on a vertical line at this point, x is equal to 6. But remember, since I'm graphing less than or equal to, I have to do a dotted line. And then I have to pick a sample point. I'll pick a sample point once again, 0, 0. But all I have to use in this case is the x value. So I'm asking, is my sample is 0, 0, is 0, because that's my x value, less than 6? The answer is true. So I'm shading everywhere in this direction. Next, we're asked, where is y greater than or equal to -2? Well, y is equal to -2 right here. It's also equal to -2 here and here, pretty much everywhere on this horizontal line. And since it's equal, I make it a solid line. I've split this into two regions now, and I want to find out if my sample, like I said, I like using 0, 0, is going to work. So I say is 0 greater than or equal to, because 0 is my y, -2, that's true. So 0, 0, my sample point, is in my solution region. Shade. Murph Found Used Bookstore. It sells pre-owned videos and CDs. The videos cost $9 each. The CDs cost $7 each. and Merv can't spend any more than 35 bucks, but it looks like it can go up to 35. We want to write an inequality that represents the situation. So we've been dealing in two variables today, so we're going to have to call one of these guys x. I'm going to call my videos x and my CDs y. And we know that if we bought one CD, it would be $9, two CDs, 18, three CDs, or three videos, sorry, it would be 27, etc., etc. One CD would cost 7, two CDs, 14, three CDs, 21. If I wanted to keep doing that for any combination, I could use my variables to get this done. I take the cost, which is $9 each, and multiply it by the number of videos that I have, 9x. Then if I want the total cost, I add to that the CD cost, which is 7 for every CD. And I have to spend no more than $35. So that's less than 35, but it could equal 35. So it's less than or equal to. And there's my inequality that represents a situation. And we want to know if he's got enough to buy 2 videos, 3 CDs. Well, my X is my videos, my CDs is my Y, and if I plugged in, I could certainly figure this out. 2 videos are going to be 9 times 2, and 3 CDs are 7 times 3, and I want to know if that's less than or equal to 35. This is 18 plus 21. Is that less than or equal to 35? And we know it's not, because that ends up equaling 39. So the answer to this equation is no.